Hi everyone, so today I will represent you Mathematical Modeling Chapter X in Maths Form 5. These are our group members. Before we start, what is mathematical modeling? Mathematical model is a representation of a system or scenario that is used to gain qualitative or quantitative understanding or some real-world problems and to predict future behavior. There are 6 components in mathematical modeling, which is identifying and defining the problems, making assumptions and identifying the variables, applying mathematics to solve problems, verifying and interpreting solutions in the context of problem, refining the mathematical model, and lastly, reporting the findings. So, let's take a look at a question of example how to applying a mathematical modeling in this question.
First step is identifying and defining the problem. In this problem, we know the length and breadth of the floor of a room are 6 meters and 5 meters respectively at the side of a square mosaic tile is 30 cm. From that, we will got the area of the room and the area of a mosaic tile. Now, we need to determine how many mosaic tiles needed to cover the floor of the room. The second step is making assumptions and identifying the variables. For the assumptions, we need to assume that X pieces of square mosaic tiles of side 30 cm can cover the room with length and breadth of 600 cm and 500 cm respectively. For the variables, we have P is for the width of mosaic tiles.
The next step is number 3. Applying mathematics to solve problem. In this step, we use whatever known techniques or knowledge with our creativity, and more complex equation can come out and lead to the solution. The first known formula is the formula of area, which is length times breadth. In this problem, the length and the breadth of the tile and the room is given, so the area of the tiles and the area of the room is fixed. In order to find the total number of tiles required, we created 2 mathematical modeling with 2 different techniques. The first mathematical modeling is total number of tiles required equals to area of room divided by area of tiles, and second is the total number of tiles required equals to number of tiles along the length times the number of tiles along the breadth and plus the number of tiles along the uncovered area. Step number 4 is verify and interpret solution in context of problem. Using mathematical model 1, number of tiles needed equals to area of room divided by area of tiles. Area of room is equal to the length and the breadth of the room, which is 6 meter times 5 meter equals to 30 meters square. Next, to find the area of tiles, we need to convert the unit cm to meter first by dividing 30 cm over 100. That will equal to 1.3 meter. So, because of the square shape of the tiles, we multiply it by 0.3 itself. So 0.3 meter times 0.3 meter equals to 0.09 meter square. Then we substitute all the values that we got using mathematical model 1, which is 30 meter square divided by 0.09 meter square. We will get 333.333. That will be rounded off to 333 tiles. Next, we will use the mathematical model 2, which is the total number of tiles required equals to number of tiles along the length multiply the number of tiles along the breadth and plus the number of tiles along the uncovered area. To find the number of tiles along the length, we will have to divide the length of the room by the length of the tiles, which is 6 meter divided by 0.3 meter equals to 20 tiles. Next, to find the number of tiles along the breadth, we will divide the breadth of the room by breadth of the tiles, which is 5 meter divided by 0.3 meter equals to 16.667. So we rounded off to 16 tiles. Since 16.0.3 is equals to 4.8, the breadth of the room is not fully covered. To find the uncovered part, we will subtract 4.8 from the breadth of the room, which is 5. That will be equals to 0.2 meter. 0.2 meters along the breadth will not be covered by tiles. This part will have to be covered by cutting the other tiles. The breadth of the floor left uncovered 0.2 meter is more than half of the length of the tile, which is 0.3. So we cannot break a tile into two equal halves and use both the halves to cover the remaining portion. The number of the tiles along the length is 20 and the number of tiles along the breadth is 16. So we need 20 more tiles for the last row. So we substitute in mathematical model 2, which is 20 tiles times by 16 tiles plus 20 tiles will equal to 340 tiles.
Next, the fifth step, refining the mathematical model. Solving the problem using mathematical model 1 and 2 has different answers. In this approach, we assume that the length and breadth involved are integers only. In reality, the length and breadth probably involve decimal. Mathematical model 2 that involves a more specific calculation is a better mathematical model in solving this problem. Lastly, reporting the finding. Report the finding at the problem solving based on interpretation of solution as shown in preceding section.